This is 6.1, matrices and systems of linear equations. So first, the definition of a matrix. It's a rectangular array of numbers. It's basically used to organize information, and it's made up of rows and columns. So here's a set of data, male and female, and we break it into three different categories of immature, juvenile, and adults. And you can see the numbers of the males that are immature males, the juvenile males, and adult males, and the same thing with the females. It's just broken down into a matrix. And we basically would take this data, just the actual numbers, and we're going to put brackets around them, and that's what's going to make up it's a row, it's two rows and three columns. And so that's what a matrix is. It's just a set of data. So an augmented matrix is the same information as a system of equations, and we just got done doing this as an example, but in a more simpler manner. So here's a linear system. You guys already know how to solve a linear system. Right here is a linear system. But if I literally just focus on the actual numbers, see, notice I have 2, -1, 5, 2, -1, 5, and then I have 1, 4, 7, 1, 4, 7. And so all we're doing is, if you already know how to solve a linear system, you're going to do the exact same thing without writing all the x's and y's and z's and 3 variables or 4 variables, whatever it is. A matrix is the exact same thing of the linear systems, except without the variables. You're just going to concentrate on just simplifying the numbers. And our ultimate goal, obviously, is to find out what x and y are. And that's what we're, this represents 2x. Okay, this represents, so this is your x column, this is your y column that you're going to be dealing with. So, in general format, an M by N matrix. So notice you have a certain amount, this is a matrix of a certain size. And you may have not ever seen it written this way, but this is the first term in the sequence, the first entry. And notice it's column, it's based off of rows and columns. So you have row. So here you have rows, row 1, and it has to be column 1. And then if we go, let's go to the right. So this is row 1, but it's column 2. Row 1, column 3. And then I put the dot, dot, dot because we don't know how big this matrix is. So we're going to go all the way to row 1 and to the nth term. Again, this could be just a small matrix, but this is a general format. And so this is row 2, column 1. Row 2, column 2, row 2, column 3, and then dot, 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 all the way to row 2, column N. We don't know how many columns there are. And then it's going to keep going on and on, all the way down to row M, how many ever rows there are, and this is column 1, column 2, column 3, and then it keeps going all the way. And then the final entry is, again, depending on how many rows we have, that's M rows and N columns. So this is an M by N matrix. Now, here's some examples of just some smaller matrices. So notice I have this first first example. So notice I have row 1, and then here I have row 2. So this is a 2 by 3, because this is column 1, column 2, column 3. So this is a 2 by 3 matrix. And so let's look at this one. This is row 1. It only has one row, but it has column 1, column 2, column 3. So this is a 1 by 3 matrix. And here I have row 1, row 2, row 3. And this is column 1, column 2. So notice it's a 3 by 2. So you always put the rows first. So 3 by 2 matrix. So let's look at what an augmented matrix, we're going to write the augmented matrix from this set of equations. And notice what we're going to do is basically focus on, the variables or, the coefficients of the variables. And notice when we get to the second column, notice this has an x, y, z, and then a number. So if we start writing this, just keep that in mind. that it has x, y, z, then a number. So this is literally going to be 6, -2, -1, 4. So notice we have 3 equations, but we're going to have, this is going to be row 1, row 2, row 3, and then column 1, column 2, column 3, column 4. So I know this is a 3 by 4 matrix. All right. Now notice on the first one, this first row is your, this first column is your x's. So this is 6, 1, and notice there is no x on the third row, on this third equation. There is no x, so I'm going to put a 0 there. And then here, the next column this is your x's, this is your y's, this is your z's, and then this is your numbers, your final number here. So on the y's, I have -2. Notice on the row 2 here, the second equation, I don't have any y's at all, so that's going to be a 0. And then I have 3 z's, and then I have 1. And then finally on the last row here, I have 7 y's, 1 z, and then 5 is the number. So the augmented matrix, this 3 by 4 matrix, is that right there. So that's how you write the augmented matrix from a system of equations. Now let's actually talk about how to solve it. Now to solve it, we're going to use elementary row operations. And you might say, well, what is that? Well, go back to this. What would you do if you were solving this system of equations? So you would first start solving for an x or a y or a z. You would isolate the variable, and you would do that by, trying to cancel out the x's or the y's or the z's. And sometimes you got to multiply and then add or subtract the equations. Well, that's really what we're going to do here. That's what elementary row operations are called. So you add a multiple of one row to another, or you can multiply a row by a certain number, or 3, you can interchange 2 rows. So it's the same operations of what you would do on a system of equations. You're just going to do it with a matrix. So let's actually walk all the way through how to solve it, a system of equations, but we're doing it through the use of a matrix. All right, so here's a system of equations. So let's first write the augmented matrix. All right, so we're going to concentrate on just the numbers. And notice we have all x's, all y's, all z's, and all numbers. So the augmented matrix in this case is going to be quite simple. All right, so I wrote the augmented matrix, and notice it's a 3 by 4 matrix. And what we're going to do is start isolating the variables, or simplifying that augmented matrix into, we're going to get it all the way down to a solved set of equations or a simplified matrix. All right, so the very first thing you might want to do, and again, this represents, this first row represents the x's, and then the y's, and then the z's. So sometimes if I refer to the x's or y's or z's, you know which one I'm referring to. All right, so what I would probably do is I see these ones right here that I would want to probably cancel by, I'm just going to simply subtract row 1 and row 2. I'm going to simply subtract that. And just so you notice, I would highly suggest you keep track of what you're doing, so that way if it doesn't turn out at the end, you can go back and follow. You might not remember what you do, so it's easy to write it down. So here I'm writing row 1 minus row 2. I'm not going to touch row 1, so I'm going to leave row 1 the same way. But I'm going to subtract row 1 minus row 2, and that's going to give me my my second row here. So literally 1 minus 1 is 0, and then -1 minus 2 is -3, and then 5, and then -6. So notice what I've done. I've already started the process. I'm eliminating my x's. You didn't have to go this route. You can try to eliminate your y's or your z's, which one you want to try to do. But I've chosen to eliminate my x's because I thought that was a very easy one to do. So I want to keep with that process. So what I'm going to do now is I'm going to take row 1, and then I'm going to cancel out with row 3. Notice here I have a 3, and then a 1. So if you notice back up here, 3 and then a 1. So I'm going to basically multiply row 1 by 3, -3. So I'm going to take -3 times row 1, and I'm going to add that to row 3. So that way, if I multiply this by -3, that's going to be -3, and then I add that to +3, and then they're going to cross each other out. So if I do that, and I could multiply the whole top row by -3 and then add it to row 3. That's what I'm going to get here. All right, so what I have now is a new, this is step 1, so this is what I've done from here to here. I wrote the augmented matrix, and then I've canceled out my x's on 2 things. Now, again, what you do from here, what you want to cancel and what you want to do from here is your choice. I'm going to go and cancel my y's. But notice this row 3. I happen to see this row 3. I happen to see they all have a 2 in common. So I'm going to divide everything by 2. And then what I'm going to do is, well, let me do that as a separate step, just so we don't get that confused. I'm going to divide all that by 2, and then that will become a 1, and then I can go from there. All right, so notice all I did was I did my notation. That's half of row 3, and I just divided row 3 by 2. Now, I noticed if I want to cross, what I'm going to try to do now is I'm going to cross these guys out, and so I'm going to multiply the third row by 3, and then I'm going to add it to row 2. So that's what I'm going to do, and I'm going to come up here. So I'm literally going to take 3 times row 3, and I'm going to add it to row 2. That's what I'm going to do. So again, row 1's not going to change. So again, notice what I did is I took 3 times row 3, and then I added it to row 2, and I chose to put it in the bottom row. You didn't have to. You could put it, remember, you could interchange rows, so you could have done this and put the answer in row 2. It did not make a difference. But I put it down in row 3, and notice what I got now. Remember, the first column is your x's, second column is your y's, your third column is your z's. And so notice what I have now. I have z equals 3. If you look at just that bottom row, I have negative z equals -3, which means z equals 3. So once you find one of the variables, then what you're going to do is just back substitute it in, and then go back and work your way backwards to find out your x, to find out your y, to be able to solve the rest of it. So again, z equals 3. I would back substitute it in. Remember, this is basically -3y plus 5z equals -6, but we found z is 3. So, then we're just going to solve for y, and then once we solve for y, then it's easy to solve for x. And then back substitute that into the first equation, and then you can solve for x. So here you're going to have x equals 2. If you write it separately, x equals 2, y equals 7, and z equals 3. So 2, 7, 3 is my solution.